going to discuss. What is the difference? First point is going to be regarding oxidation state. Can you tell me what are the oxidation states are possible in the case of lanthanides? Plus 2, mostly plus 3. There are some ions that will exhibit plus 2 as well as plus 3. First point is going to be in addition to plus 3 oxidation state. First point. In addition to plus 3 oxidation state. In addition to plus 3 oxidation state. In addition to plus 3 oxidation state, they exhibit plus 2 and plus 4 oxidation state also. They exhibit plus 2 and plus 4 oxidation state. In addition to plus 3 oxidation state, lanthanides exhibit plus 2 as well as plus 4 oxidation states. Whereas actinoids, in addition to plus 3, there are other oxidation states. That means they show plus 4, plus 5, plus 6, plus 7 oxidation state. In addition to plus 3, they show plus 4, plus 5 and plus 7. Is it clear? This is the first point of difference. Second point. Second point, lanthanides do not form complexes. Lanthanides do not form complexes. Why? As when compared to transition elements, lanthanides do not form many complexes. Why? Complexes form now, what is the criteria? The ligand and the metal orbital must interact, or they should show some kind of interaction. Is it clear? Whereas in the case of lanthanides, the core of orbitals are buried. Okay. That is enough. For example, suppose you take core of a female. This will be 5 years. This will be 5B. This is 4 electrons. Next we have other orbitals. So these 4 orbitals are inside to the atom, deeply buried. Deeply buried, it cannot expose outside. So orbital cannot be exposed outside. Outside exposed ligand cannot approach the metal orbital or the lanthanide orbitals. It cannot form complexes because the 4 orbitals are deeply buried inside an atom. That's why it do not form many complexes. Because 4 orbitals are deeply buried. Okay. That means it is there inside to the atom. So it cannot orbitals cannot be exposed outside. That's why ligand cannot approach those orbitals because deeply buried. நம்ம இன்சைடா இருக்கும், அதனால லைகன்ஸ் வந்து ஈஸியா என்ன பண்ண முடியாது, ஆர்பிட்டால்ஸ் அப்ரோச் பண்ண முடியாது. தட் இஸ் a point. Next, whereas actinoids they have much more tendency to form complex. More tendency to form complex. So previous question. It is complex formation tendency. What is the answer? Correct incorrect statement like it. Next, third differences. So they do not form oxo anion. Oxo anions. Lanthanides do not form oxocation, whereas actinoids form oxocation. Examples: uranium oxocation, U O2+, oxocation, plutonium oxocation, oxocations are possible in the case of actinoids. Next to the point of difference, the fourth point of difference. Okay. Lanthanide compounds are less basic. Lanthanide compounds are less basic. Whereas lanthanide compounds are more basic. Next, the fifth point of difference. Lanthanides are non-radioactive except promotium PM. Lanthanides are non-radioactive except promotium. Whereas actinoids are radioactive elements. Next, the sixth point of difference. There you go. Sixth point of difference. Their magnetic properties can be easily explained. Magnetic property can be easily explained with lanthanides. Magnetic properties can be easily paramagnetic also diamagnetic. Magnetic property can be easily explained for lanthanides, whereas magnetic property cannot be easily explained for actinoids. Magnetic property can be easily explained for lanthanides, whereas in this case magnetic property cannot be easily explained for actinoids. Is it clear? So these are the 6 point of differences between lanthanides and actinoids. Magnetic property can be explained easily. Magnetic property cannot be easily explained. Is it clear? So these are the few points regarding. Next, shall we go for that's all. This point is over. DNA. This is block elements. Next, shall we go for the questions? Questions to the mind. So what is the correct electronic configuration of lanthanum? Correct electronic configuration. Electronic configuration. Configuration of lanthanum. What is the correct electronic configuration of lanthanum? 4 options. You tell me the correct option. The correct electronic configuration. Atomic number is going to be lanthanum atomic number 57. Okay, this is going to be 0. This will be 0. 4F0 is 0. 5D1 6S2. The current electronic configuration is going to be into 56 plus 3 57. Now we know that lanthanum is going to be 57. Now is going to be 57. Is it clear? Yes or no? Lanthanum is lanthanum is not required, but please note this. F block elements is not D block elements. Please note this. Lanthanum is not D block elements. Please note this. It's not a block elements. Next question. First question. Second question. The basic nature of hydroxides. decreases from basic atom decreases from cerium to lutetium. Cerium to lutetium. This is due to what would be the reason? This is due to why the basic nature is decreasing from cerium. The first option is going to be decrease in ionic radius. Decrease in ionic radius. The correct option is going to be decrease in ionic radius. The correct option is going to be decrease in ionic radius. Decrease in ionic radius. Decrease in ionic. Which one is more basic in data? Cerium hydroxide. Least basic in data. Lutetium or lutetium hydroxide. Lutetium hydroxide. Please note this. Second question. Which of the following lanthanoids? Which of the following lanthanoids has smallest atomic radius? Smallest atomic radius. Option A, cerium. Option B, lutetium. Option C, europium. Option D, gadolinium. What is the option? Lutetium, because left to right corner. Size decreases due to. Size decreases if you move from cerium to lutetium. Oh, what is the reason? Why decreasing? Poor yielding of F4F orbital. It is called lanthanoid contraction. The answer is going to be B. Okay, it's going to be so lutetium is going to be the smallest atomic radius. Next question. Which of the following elements belongs to actinide series? Which of the following elements belongs to actinide series? Which of the following belongs to actinoid series? First one is going to be lanthanum. Second option is going to be gadolinium. Third option is going to be lutetium. Fourth option is going to be thorium. Answer is going to be thorium. Next question. Cerium, atomic number 15, and ytterbium, YB, atomic number is going to be 17. Exhibits stable electronic configuration. Exhibits stable +4 and +2 oxidation state. This is because this is due to the reason. Cerium +4, ytterbium +2. What is the reason? The reason is going to be cerium +4 and ytterbium +2 is due to. The correct option is going to be 4F0 and this is going to be 4F14. This applies 4F0 and 4F14. Ytterbium 2 plus 4F14, cerium +4, 4F0. Next question. The transuranic elements begins with transuranic elements begins with trans-uranium start off. First option, neptunium, curium, plutonium, uranium. Trans-uranic elements begins with, let's start off, neptunium. Answer is going to be trans-uranic elements after uranium. Is it clear? The correct option is going to be neptunium, that is N. Next question. Next question. Next question. Zirconium. Zirconium, that is Z or atomic number 40, and hafnium atomic number is going to be 72. Have similar atomic and ionic radius. Atomic and ionic radius. Atomic ionic radius because of why these two have similar atomic and ionic radius? What could be the reason? Lanthanide contract. Answer is going to be lanthanide contract. So we have discussed this point. This is the reason because the correct option is going to be lanthanide contraction. Lanthanide, your previous year question. Lanthanide contraction. This is the lanthanide contraction example. Scandium, yttrium, lanthanum. Is there a lanthanide contraction of the form? No. Next one. Titanium, zirconium, hafnium. Is there a lanthanide contraction of the form? Yes. The size is going to be similar. Size is going to be similar. Depending on titanium, it's going to be smaller in size. Next is zirconium, it's approximately is equal to. Similarly, in the book, vanadium, niobium, tantalum. This is lanthanide contraction of the form. Yes. Vanadium, smaller in size. Niobium, approximately is equal to tantalum. This is because of lanthanide contraction. Similarly, next element energo. Next one is chromium, molybdenum, calcium. This energo, lanthanide contraction. This energo, lanthanide contraction order results in the size, the 4D, size of 4D will become, or you can say the size of 5D will become equal to 4D, approximately equal to. Next question. Next question. Next question. Incorrect statement. Incorrect statement. You have to pick the incorrect statement. Incorrect statement. Statement 1. Actinides are highly reactive. Actinides are highly reactive metals, especially when finely divided. Actinides are highly reactive metals, especially when finely divided. Is it correct or incorrect? Yes, correct statement. Is it clear? Actinides are reactive metals. Is it clear? Actinides are highly reactive metals, especially when finely divided. Let's go fine and divide for now. Second point, actinide contraction is greater for element. Actinide contraction is greater for element. Actinide contraction is greater for element to element than lanthanide contraction. Actinide contraction is greater for element to element than lanthanide contraction. What about this statement? And actinide contraction is greater for element to element than lanthanide. Which one is greater? Lanthanide contraction or actinide contraction? 4F and 5F. actinide contraction is greater when compared to lanthanide. Please note this. Second statement is going to be correct. If actinide contraction is going to be more than lanthanide contraction. Clear? Is it clear? Yes or no? Last point. Next point. Please notice actinide contraction always is going to be greater when compared to lanthanide contraction. One point. Correct or incorrect? Yes, is a correct statement. Third point. Most of the trivalent lanthanide ions. Most of the trivalent ions are colorless in solid state. This is the incorrect statement. Most of the trivalent now lanthanides Ln3 plus. Ln3 plus are colored. Ln3 plus are colored. But in colorless colored in aqueous as well as in solid state. Please note this. Therefore, most of the lanthanide ions are lanthanide 3 plus ions are colored. Is it clear? In aqueous solution as well as in solid state. In solid state. Anyway, colored are but in a given statement colorless. So this is incorrect statement. Please note this. Lanthanide ions are colored in aqueous as well as in solid state. But the given statement is colorless. So incorrect statement is now. Is it clear? Next. Again. Next, please. Next question. Next question regarding D block elements. Yesterday we have discussed. Will you go? When neutral or less basic medium or less alkaline medium. Alkaline K1O4 is treated with potassium iodide. Is treated with potassium iodide. A. Iodide ion is converted into that means K1O4 medium neutral or less alkaline medium. If I treat with Ka, this I minus IO3 minus, that is iodide. Option option A IO minus, option B I2, option C IO4 minus, option D IO3 minus. What is the correct option? Very important. IO3 minus is very important. Is it clear? Yes or no? Whereas in the case of acidic medium data, I2. Please note this. This is a previous question. In the case of neutral or alkaline medium, IO3 minus. Acidic medium, I2. Please note this. This is acidic medium. This is acidic medium. Okay. Next question. Next we go. Again, this is regarding D block elements. Which are the following ions exhibit DD transition as well as paramagnetic? Which are the following ions exhibit DD transition as well as paramagnetism? Which are the following ions exhibit DD transition as well as paramagnetic? DD transition as well as paramagnetic. The first option is going to be paramagnetic as well as DD transition. DD transition exhibit one as well as paramagnetic. The first option is going to be CrO42 minus. Second option CR2O72 minus. Third option, Mn O4 2 minus. The fourth option, MnO4 minus. What is the correct option? Which one exhibits DD as well as paramagnetic? What is the oxidation state? Plus 6. Plus 6. Plus 6. Plus 2 clear? So, here D0, D0, D1, D0. Either DD transition no? No. Because element no D electron. D electron or DD transition exhibit no. But this one, whatever answer electron, so paramagnetic. Is it clear? So you have to see the oxidation state. Next question. Next question. The reason for greater range of oxidation state. The reason for greater range of oxidation state. Greater range of oxidation state in actinoids. In actinoids. Reason for greater range of oxidation state in actinoids is due to answer. Yes. The energy difference, or you can say 5F. Reason is 5F 6D 7S levels. 5F 6D 7S levels have comparable energy. 5F 6D 7S levels having comparable energy means energy difference is less. 5F2 6D 7S or energy level is going to be less. That's why it exhibits greater range of oxidation state. So clear? When compared to lanthanoids, when compared to energy difference is going to be very less. The energy difference is going to be very less. Next. Which of the following is going to be incorrect statement? Incorrect. Incorrect statement. Statement 1. This is correct or incorrect? Correct. European EU. European source plus 2 oxidation state. Correct or incorrect? Correct. Second point. Basicity decreases. Basicity decreases. Basicity decreases. Basicity decreases from Er2 potassium. Promoting PM layer. P or not? P on. P or not? Residomium. Residomium. Okay, pronounce pronoun. Basic character now left to right over. So in the statement correct. Basic character decreases from Pr to lutetium. Correct or incorrect? Correct. Third point. All lanthanum ions are more reactive. All lanthanum ions are more reactive than aluminium. Please note this point. Please note this point. This is an incorrect statement. Lanthanum ions are less reactive when compared to aluminium. Kuduthuka statement more reactive kuduthukanga, but actually aluminium is more reactive when compared to lanthanum. But inge ultava kuduthukanga, the points are not nichko. All lanthanum ions are more reactive than aluminium kuduthukanga is an incorrect statement. All lanthanum ions are less reactive when compared to aluminium. Aluminium is more reactive when compared to lanthanum. Please note this. Aluminium is more reactive when compared to lanthanum or lanthanide ions. Is it clear? Please note this point. Next, the last point is last point. This is an incorrect statement. Additional point. Cerium plus 4 is used as an oxidizing agent in volumetric analysis. Correct and correct. Cerium plus 4, NOx form, oxidizing agent. Next. Again, next. Next again, D block elements. D block elements. Clear? Which of the following statement is correct? Which of the following statement is correct? When SO2 is passed through acidified potassium dichromate. Okay, you have to pick the correct statement. When SO2 is passed through acidified potassium dichromate. The meaning is potassium dichromate. What are react pannanum? SO2 oda react pannanum. Table paru. SO2 enna maarum? SO4. SO2 enna maarum? Look at the table. SO4. That means plus 4 and enna maarum? Enna maarum plus 6. Appo idu enna maarum? Chromium in acidified chromium. In acidic medium enna maarum? Enna oxidation state la convert agum. Chromium plus 6 level enna agum? Plus 3. Chromium plus 3. Plus 3 नाले इन्हें color कुछ लेंगे. Green color. क्या color? Green color. Please notice. इधर reaction. इसमें क्या? Statement है कितना है? So, is an oxidizing agent. In acidic medium, it will oxidize sulfur dioxide to sulfate ion plus 4 to plus 6, and itself reduces from plus 6 to plus 3. இதோட color red orange. ये ना वाला green color. இதோட application என்ன சொல்லுங்க? So clear? எங்க apply பண்ணலாம் சொல்லுங்க? Drunken dry சொல்லுங்க இல்லையா? Just remember this point. Orange color என்ன வரும்? Green color. The green color because of Cr3+. The green color because of Cr3+. Is it clear? Next question. The correct electronic configuration of europium and gadolinium and terbium. Correct electronic configuration. We know this. Correct electronic configuration of europium, gadolinium and terbium. The neat question. What is the correct electronic configuration? You just copy from your notebook. Europium EU, ZD gadolinium, TB terbium. Europium, gadolinium, terbium. Take it first. Next. The reason, next question. Please copy electronic configuration of europium, gadolinium and terbium. Here D electrons are gadolinium. In a configuration 4s7 5d1 6s. List of first 7 elements first 7 elements in the lanthanides. Cerium, at least simple matter cerium, neon, Ne, Pm, Sm, U, Gd. D. This is important. Gd, EU, Gd, EU and Pm. Cerium. EU, Ce and Gd. Is it clear? Next symbol. Tb, Dy. Next. This one. HO, ER, EM, YB, LB. Is it clear? Yes or no? Next question. The reason of lanthanide contraction is. We have to previous year question. The reason of lanthanide contraction is Lanthanide contraction la enna reason ஆதா இருக்க முடியும்? Poor scholar negligible screening of negligible screening effect of F orbital. Negligible screening effect of F orbital. Negligible screening effect of. Next question. Next question. Which of the following exhibits poor screening of poor shielding effect, screening effect, shielding effect எல்லாமே உண்டு. Is it clear? Next, which of the following exhibit only +3 oxidation state? Only +3 oxidation state. Only +3 oxidation state. Plutonium, option A. Uranium, actinium, and protactinium. Option PU. Uranium, option. Thorium. Option 3, actinium, and protactinium. Option 4, PA. Which one will exhibit only +3 oxidation state? In the case of actinoid series, which one will exhibit only +3? Uranium, the stable oxidation state, +6 states. Is it clear? Thorium in a configuration 5F0, 6D2, 7S2 here. You can exhibit +4. Is it clear? You can exhibit +4. Next is actinium any elements है? D block electronic configuration है? Random electronic configuration है? 5D1, 6S2. அதுக்கு தான் actinium இருக்கும். அப்போ 6D1, 7S2. Only one oxidation state +3. The reaction is going to be clear. Is it clear? Next question. So again the question of which of the following oxidation state is the most common among the lanthanides? +3. Most common oxidation state of lanthanides +3. Next question, incorrect statement. நான் சொல்றேன் கரெக்டா இன்கரெக்டா மட்டும் சொல்லுங்க. As a result of lanthanide contraction, the properties of 4D series. As a result of lanthanide contraction, the properties of 4D series. The properties of 4D series of the transition elements. As a result of lanthanide contraction, the properties of 4D series of transition elements have no similarities with as a result of lanthanide contraction, the properties of 4D series of transition elements have no similarities with 5D series of elements. Correct or incorrect? Incorrect. என்ன property same இருக்கும்? Radius. என்ன இருக்கும்? Incorrect statement. Next question. Let me repeat that. Next one, the general electronic configuration of lanthanides. General electronic configuration of lanthanides. So what is the general electronic configuration? N-2, F, 1 to 40, N minus 1 D 0 to 1. Please note this. And NS2. General electronic configuration of next, the correct order of ionic radii. Correct order of ionic radii. Correct order of ionic radii. But I will give ions to arrays. That is going to be ytterbium 3 plus this, yttrium 3 plus not ytterbium, lanthanum 3 plus, europium 3 plus, and lutetium 3 plus. Can you arrange these 4 ions based on ionic radii? Is the radii serving on? Which one has more radius? Or elements which is scandium, yttrium, lanthanum. This is like lanthanum contraction. Lanthanum contraction is helpful. इसलिए वो round the group now size increase हो. Size now increase. So lanthanum 3 plus is going to be more when compared to yttrium 3 plus. Correct? Next, among this one. Left right को size now decrease हो. Arrange करना. Left right one. Tail size अभी आपको lanthanum 3 plus is going to be more. Option. Then right. Lutetium 3 plus. Correct order. Europium 3 plus. The lanthanum 3 plus. This is correct now. We have lutetium 3 plus. Then we have europium 3 plus. Then we have lanthanum 3 plus. Among this one, which one is correct? Among this one, which one is correct? Which one is correct? Lanthanum is going to be greater atomic radius when compared to other. Lanthanum the ஒரே ஒரு option தான் இருக்கு. इसलिए lanthanum is going to be more. Lanthanum के அடுத்து தான் lanthanum contraction. Lanthanum contraction size is going to be decreases. So here, அப்ப lanthanum the ஒரே ஒரு option is the option. Next question. Okay, we're going to discuss what lanthanides are. Lanthanides are correct option also है. Correct है नीचे को निको 14 elements in the 6th period. Correct है incorrect. Lanthanides are 14 elements in the 6th period. Correct. Actinides are 14 elements in the 7th period. When does it start out? Lanthanides. You see atomic number 58 to 70. Non-option கொடுத்துருவாங்க. Next. Which is not correct? Which of the following statement is not correct? Which of the following statement is not correct? Which of the following statement is not correct? The first statement, lanthanum 3 plus, lanthanum, that means lanthanum hydroxide is less basic. Is less basic. Here are the questions now. Okay, less basic than lutetium hydroxide. Is it correct or incorrect? Incorrect. Here are incorrect. Next is in lanthanide series. In lanthanide series, ionic radius of lutetium 3 plus. Lanthanide series, In lanthanoid series, ionic radius of lutetium 3 plus ion decreases. Appropriate size. Next, lanthanum is actually some transition elements. Correct or incorrect? Lanthanum, La, correct. Some transition elements. F block elements start. Cerium start. Next, atomic radius of zirconium and osmium is going to be same. Correct? Correct. Okay, so these are the questions. These are the previous year questions. Second option. Second option is ionic radius from cerium to lutetium. Decreases or increases? Decreases. So these are the previous year questions. But what you do? You have NCERT, you have to read line by line. Please keep this point in your mind. Okay? You will take the D block and F block. You will have weightages with it. 2 questions. You have weightage, 2 questions. Particularly questions will be asked from electronic configuration. The remaining properties is just your electronic configuration and lanthanide. So Monday onwards we will go for P block. P block preparation only properties. P block preparations only properties. Properties model. Is it clear? First time முடிச்சோம். Whereas for your for NCERT needs to only properties model. Not how many chapters are remaining? How many chapters?